today's Leetcode daily challenge question. So the question is partition equals subset sum. So given an integer array nums, return true if you can partition the array into two subsets such that the sum of the elements in both subset is equal or false otherwise. So highlight is two subsets and the sum of elements in both subset. If it is equal, then we have to return true, else false. Okay, so if we see this example nums 1, 5, 11 and 5, it is returning true. Why the array can be partitioned as 1, 1, 5, 5 and 11, as here it is mentioned subsets, not subarray. Okay, subset can be like here is you can see 1, 5, 5. Okay, subarray is different, which is continuous. Okay, so consider here highlight word is subset. So here you can see they are partitioned into two subset and the sum is equal, that is why it is returning true. Similarly nums 1, 2, 3, 5, array cannot be partitioned into equal sum subsets. Like if you do 1 and 2, 3, 5, then it is 3 and the sum is 5 plus 3 is 8 and like that. Okay, if you do other combinations also, there is no array which like no two subsets which we are getting for equal sum. Okay, so how we will solve this question is we will go step by step. Okay, so first thing is we need a subset. Consider this is subset 1 plus subset 2, which is what our array. Okay, so what we want, sum of subset 1 plus sum of subset 2. Okay, this should be equal. That means if we say this, we can say 2s1, that means 2 subset 1, which will be equal to a1. I'm trying to say this sum of a1, all the elements in an array will be sum of this. That means sum of s1 equal to sum of a1 divided by 2. That means if we are getting any subset which has uh, which has sum of total elements divided by 2. So for example, if we take this thing, okay, 1 plus 5 plus 11 plus 5. How much it is? 11 plus 1 is 12. 12 plus 10 is 22. So if we divide by 11, if we are getting any subset which has some 11, that means we have other also, because we want both the like sum of both subset. Okay, so this we have to consider. This is the first thing. Okay, so we have to find the subset which has sum equal to total sum divided by 2. Okay, instead here I will write total divided by 2. Okay, now we have to find a subset, okay, which has sum is total divided by 2, which we can solve. How we will find that is, here it is given two subset. So subset means either this is 1, 5, like you have choice that you can include this element in subset or not. Same thing for this. So here what they did, if we see, 1 is included in the subset, yes. 5 is included in the subset, yes. 11 is included, no. 5 is included, yes. So this is one subset. Okay, so yeah, so this is one subset, so you have choice. Okay, in my previous video also, if we see, choice means recursion, there is a possibility of recursion. Okay, and if we have multiple choice, then recursion too we can do memoization. Okay, so let's see how recursion is. I will use paint for that. Okay, so let's see what was our this 1, 5, 11 and 5. Okay, so if we see, first is what, first is empty. So what choices you have is either include one or not. Okay, so if you include one, so instead of this what we will do, okay, include one, Okay, and not means just empty. Again, again in the next, what two choices have for these two is include 5. So 1 and 5 or not. That means only 1. Okay, here is include 5 and or not. Again, for this is include 11 or not. So if we include 11, it will be 1, 5, 11 or just 1, 5. Okay, for this it will be 1 and 11. Here it will be only 1. Okay, and for this it will be 5, 11 or it will be just 5. Or for this case it will be, okay, I'll take here, it will be 11 and empty. Okay, again we have one more is 5. So if we include here 5, what we get is 1, 5, 11 and 5. Okay, if we don't, then what we will get 1, 5, 11. Again, for this if we include 5, what will get 1, 5 and 5, and if we don't include 1 and 5. So basically we are getting all the subsets, you can say. So it will be 1 comma 11 comma 5, 1 comma 11, 1 comma 5, 1, and again 5 comma 11 comma 5 or 5 comma 11 or 5 comma 11 or just 5. So similarly here 11 comma 5 or just 11. Okay, so these are the possibilities. Okay, so what is the sum? Sum is here, it will be 1 plus 5 plus 11 plus 5 is what? Is 22. Again same, if we find the sum of all, here we get 11 for this 1 5 5. And what we want in our this here, what we want 11, sum as 11. Okay, here it was divided by 2 and we got yes. So we can say return true. But see, here what we are doing, we are finding all the possible subsets, okay, using the recursion. But it will be giving us a TLE. So let's first code this and improve the code. Okay, so we can use one more method, public boolean can partition recursive. Okay, here what we will pass is first we need nums array, then we need the index as we are going here next one by one. So we have choice this element to include or not. Okay, just okay. So int I, and we need a target. So instead of finding this array, what we will do, we will find the sum only directly. Okay, we will find the, instead of this storing this, we can find directly the sum and check, right? So int target, here what we will do is before that, okay, before that what we here did, or let's say first complete this, is if our target is 0, okay, that means what we will do is we will return true. Why? Because every time what we will do here, it is our target, so I will be passing 11 here. So every time while going to the next call, if we are including that element, that means we will reduce that from our target. Okay, So that means here our target was what? 11. If I am including 1, the target is 10. If I am including 5, my target is 5. And if I am including, let's go this side. If I am including okay, here for this again 5 we are including, right? If I am including again 5, that means my target is 0. That means I got my subset. So we will return true. Next, when we will return false is if my I is greater than or equal to nums.length, or that means my I, as every time we will be going to the next, like 1 2 3 0 1 2 3 4. If it is greater than nums.length, of course we will return false, or target is less than 0. As here I was explaining, for target as equal to 0, here if we go, as I said, 11 minus 1 is 10. 10 minus 5 is 5, and again 5 is there, and if we do 5 minus 11, it will be negative, so we can't go in this, so we will just return false. Okay, so here we will return false. And what are the calls which we have to do is return same thing. Okay, I mean same thing means same this method where nums will be same, I will be I plus 1, but either include or not include. If we are including, that means target minus nums of I. If we are not, that means I'll use or nums comma I plus 1 comma target, just as we are not including. So these are the two choices. So every time we will find this. Okay, as we are finding this target, we will reduce every time. Okay, so before to call this, what we will do, first we will find a sum as we discussed this. Okay, and we have to pass that as target. And also see, if our sum is odd, that means we cannot. If our sum is 41 and if we divide by 2, it will be in a point, so it is not possible. Okay, our these are integers. Okay, so int sum is equal to 0 for int num of nums, sum plus equal to num. If my sum percent 2 is not equal to 0, I will return false. Okay, else what we'll do, we will return this call with nums. Initially it will be 0, and target will be sum divided by 2. Okay, let me just run this. Accepted, but if we submit this, let's check. Yeah, you can see time limit exceeded, because here you can see every time it will be doing this all the calls, right? Unnecessary. So here you can see we have this 1 and 5, again we have this 1 and 5, and like it will be, if we have the same, instead of saying this 1 and 5, I can say if we have this same sum for any of the this call. Okay, I mean that I syntax, that we can store and memorize this thing. Okay, instead of calling again and doing the same thing. Okay, that is why we use the memoization, right? So what we will do, we are going to use one 2D array, okay, which will help us to store the results of this I and target. Okay, so for that I plus 1, or this I plus 1 and this target. Okay, instead of that I can say for this I and target, if we have already the value in our this table, sorry, 2D array, then we don't have to again calculate. Okay, just, so what we will do, we are going to use 2D array boolean, or let's say memo is equal to new boolean. What it will be, first is nums.length, and here it will be having sum divided by 2 plus 1. Okay, so that means this, here it will be I, first will be I and second will be sum divided by 2 plus 1. Okay, Now here we will pass this memo. So here we have to update this as boolean memo. Okay, so same thing every here it will be same, but what one more condition is, if my memo of what, as I said here, what we are using nums dot length, so I and the target is not null, as we are using this boolean, not this boolean. Okay, so we are using the wrapper class, so I'm checking not null, then we will return what, return that memo, that means this, we don't have to calculate again. Okay, and again how we will store and when we will store. So instead of this, I will just cut, and here I will do, here if it is not there, then we will store this in that, and then we will return this memo. Let's check. Yeah, you can see, wait, oh yeah, here it should be 2 here, right? Still there's something where, yeah, here we have to update, right? Here also we have to pass the same thing, as this was our recursion wala code. Now we have to update accordingly our new method where we are passing this memo. Yeah, you can say accepted. Let's submit this. As we are getting for recursion, we were getting the TLE. So here you can see accepted, and with the it beats 85.83% of people. Okay, so this was a memoization approach. Okay, so how, like, what is the thinking process? First we thought of sum, and then as we have this formula, like this analysis we did, and then again we had choices. So if we have choice, then recursion, and if we have recursion with multiple calls, then we can think of memoization, where we can store the values which are repeating. Okay, here instead of saying the, what you can say, mm, instead of like here 1 file 11 I'm getting again for this 1 file. Okay, here we are getting multiple things again and again, right? So it will be like, for some we are checking the sum, not the numbers. Like I'm not saying 1 and 5 only, 1 and 5 only. Okay, so I'm saying for the, for that call, okay, for that thing, here I can have multiple things, right? For that, this, you can, this level you can say, for each level, if we have the same call, okay, with same sum and the index I, or same sum you can say, because as we are referring to the same level, then we don't need to calculate, and we can just return that. Okay, so if you feel this video is helpful to you, please like this video and subscribe my channel. Stay tuned. Thank you so much.